Hello there and welcome to my video on the ratio test. The ratio test is a test for absolute convergence. So in previous videos we took a look at the alternating series test to determine if an alternating series was convergent or divergent. Then we took a look at absolute convergence, and absolute convergence was we tested using a variety of different tests to determine if the series converged absolutely, which means whether the terms were alternating or whether the terms were all positive, the series would converge. So the ratio test is a test for absolute convergence. It's a very nice test to use when you can use it. So we start with a series. We have a series summation from n equals 1 to infinity of a sub n, and we then take the limit of that series. If we take the limit of the absolute value of a sub n plus 1 divided by a sub n. Now a sub n plus 1 means we're adding 1 to every value of n. And then we are taking the absolute value of that. So the absolute value of the ratio of a sub n plus 1 divided by a sub n, and then taking the limit of that as n approaches infinity, if that is less than 1, then the series will converge absolutely. Okay, converges absolutely. If, on the other hand, the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub 1 is greater than 1, then it diverges. The series will diverge. And finally, what happens if it is equal to 1? Well, if the limit as n approaches infinity of a sub n plus 1 divided by a sub 1 equals 1, then this test is inconclusive and we have to go to another test. Inconclusive. All right, so less than 1 converges absolutely, greater than 1 diverges, and there's no need to do the alternating series test or anything. And then if it's equal to 1, it is inconclusive. And when I say greater than 1, I'm also including in that infinity, because infinity is greater than 1. So if the ratio is greater than 1 or infinity, it will diverge. And that is the ratio test. Now there's some tricks to doing the ratio test, so I'm going to do a couple of quick examples. The first example I'm going to do is the series of 5 to the n over n factorial. Now up until this point in time we have not had any factorials. When you see that you have a factorial in your series, think the ratio test, all right? The ratio test is a great way to deal with any type of a series that has a factorial in it. So remember, we've looked at factorials before, but to remember what a factorial is, as an example, if we have 5 factorial, 5 factorial simply means we're taking 5 times 4 times 3 times 2 times 1. That's what a factorial is. Or 3 factorial is 3 times 2 times 1. So we have n factorial for whatever n is going to be. Well, this then becomes my a sub n. And so the first thing I need to do, this is a sub n. I need to create an a sub n plus 1. So a sub n plus 1, I simply go to every value of n and add 1 to it. So I will have 5 to the n plus 1. N factorial, I will have n plus 1 factorial. All right, so now we want to take the limit. So I'm going to take the limit as n approaches infinity of the absolute value of 5 to the n plus 1 divided by n plus 1 factorial. And I'm going to divide that by 5 to the n over n factorial. So I'm writing it as a division problem rather than a complex fraction, just for this, it's a little bit simpler to write it this way. Well, we then want to change this to 5 to the n plus 1 over n plus 1 factorial times the reciprocal of this, n factorial over 5 to the n. Whoops. That doesn't look like a 5. There we go. 5. All right, because remember we just changed division to multiplication by the reciprocal. All right, now this is the fun part. This is where we actually do some algebraic manipulating. So what I'm going to do here, 5 to the n plus 1, remembering our exponent rules from algebra, when we multiply two bases that are the same, we add the exponents. So as an example, if I multiply x cubed times x squared, I am keeping the base and I add the exponents, 3 plus 2, to get x to the 5th power. So if I had x to the 5th power, I could break that up into x squared times x cubed. I could factor it. And so that's what we're going to be doing here. So 5 to the n plus 1 could be rewritten as 5 to the n times 5 to the 1. All right? So 5 and 5, the bases are the same. We're multiplying the bases. We simply add the exponents, n plus 1. And that's what we have over here. Another cute little algebraic thing we're going to do, n plus 1 factorial can be rewritten as n plus 1 times n factorial. Now here's why. Let's just say as an example we have 8 factorial. Well, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, I could change that to 8 times 7 factorial. I could change that to 8 times 7 factorial. So all I'm doing is then saying, okay, well, I've got my 8, and then all of this becomes 7 factorial. Well, that's essentially what I'm doing here. Think about that. So I'm starting off with n plus 1 factorial. My n plus 1 is essentially the 8. And then the n factorial would be the 7 factorial. So play around with that a little bit. Let me know if that makes sense or doesn't make sense. I can do a little bit more explanation on that. So what we're going to do here is we're going to have n plus 1 times n factorial times n factorial over 5 to the n. Well, now we can start doing some canceling out algebraically. 5 to the n, 5 to the n, n factorial, n factorial. And so what we left with is the absolute value of 5 over n plus 1. All right, well, now we can see as we take the limit of this, the limit as n approaches infinity, this is getting infinitely large. This whole thing is approaching 0. And 0 is less than 1. And if the limit of that ratio is less than 1, it converges absolutely. So this particular ratio, this particular series will converge absolutely. One more example. In this example, let's do 8 to the n over n squared. Okay, that is my series, and we want to test it for absolute convergence. So first of all, let's figure out what a sub n plus 1 is, because this would be a sub n. So that's simply going to be 8 to the n plus 1 over n plus 1, oh, not factorial, n plus 1 squared. So I'm just adding 1 to every term that has an n in it. Now I want to take a limit as n approaches infinity of the absolute value of 8 to the n plus 1 over n plus 1 squared times, I'm just going to skip the division part and go to multiplication by the reciprocal now. Okay, so n squared over 8 to the n. So once again, it's a sub n plus 1 divided by a sub n, or times the reciprocal of a sub n. The next thing to do is to simplify. So 8 to the n plus 1, just like I did in the last problem, would be 8 to the n times 8 to the 1. N plus 1 squared, I'm going to actually expand that out. N squared plus 2n plus 1 times n squared over 8 to the n. Okay, now let's just cancel out anything that cancels out. So 8 to the n cancels out with 8 to the n. And so what we are left with is the limit as n approaches infinity of 8 times n squared over n squared plus 2n plus 1. Now, we want to take the limit of this. So just like we've done in some previous videos, we look for the highest power of n and divide all the terms through by the highest power of n. So that would give me the limit as n approaches infinity of 8n squared divided by n squared divided by n squared over n squared, 2n over n squared, and 1 over n squared. Need some more room up here. I'm going to go up here. So now this limit as n approaches infinity, 8n squared divided by n squared just becomes 8. N squared divided by n squared becomes 1. 2n over n squared becomes 2 over n. And then 1 over n squared doesn't simplify. We just have 1 over n squared. All right, so now we want to take the limit of that as n is approaching infinity. So as n approaches infinity, like we've seen many times before, in this term, as n gets infinitely large, this term becomes 0. As n becomes infinitely large, this term becomes 0. So what we end up with then is the limit is 8 over 1. The absolute value of 8 over 1, which of course is 8. So since the limit is equal to 8 and 8 is greater than 1, we know by the ratio test rules that this diverges. That's all there is to it. The most complicated part of these is probably figuring out how to break up some of these terms, especially with the factorials. And I've got some more examples in my notes. And if you guys want me to, I can do some more examples. Just let me know. It doesn't take long to do it. And that's that. That is the ratio test. I will see you in class.